All right, so we are going to tackle this with QM, and here we go. We are looking now at the module decision tree. I've done the graphical decision tree. We've got our decision node to start. So what's the first decision that we make when tackling this problem? And the answer is, well, we've got we really in this case are deciding which of the three to do right now. So we're going to build a large client with, we're going to either do the equipment right away, or we'll delay the equipment or do nothing. Okay, so I'm going to plug that in immediately. Now if you're doing a survey before you do anything, that would be your first decision. We're going to add 3 branches. All right. So now let's see, here we go. My numbers for, or my label, excuse me, for this is the equipment simultaneously decision. This one is equipment delay, and then this one is nothing. In the nothing node, it just terminates here, generates 0, so that's it. So let's talk about if we do the equipment simultaneously. Well, if we go back to our description of the problem here, if we do it right away, we have to determine the demand. We have a 50-50 demand probability, and then we're going to generate some revenue, either 1.8 billion or lose 900 million. So that is an event node. So we'll add 2 branches, and we have to keep the probabilities, and we'll get 1,800 million if it goes well, and we'll lose 900 if it goes poorly. Right, this is good demand, and this is bad demand. Okay, so that's it. That's our solution for that side. Now if we delay, notice we've got this. First thing we need to resolve is that if we delay, we have a 10% chance that another firm gets to the market first, and we get nothing. So let's take care of that right away. Now, you wouldn't have to do it that way. We could decide, we could have the demand appearing first. The key though is that the decision we still have left to make in this branch is whether to actually build the equipment. Right? We can build the building and then choose not to build the equipment. And that's the same as getting beat to market. So we'll generate no profit if that happens. But that's a choice we can make. So, and that's after we find out about what the appearance of the demand looks like. So we don't know the actual demand, but we have some kind of signal from delaying a bit. And so you can kick out that 10% anywhere in the process, but it makes sense to do it right away. And that's more consistent with the time. So I'm going to go right away, add 2 branches. This one's got a probability of 10%, and it's going to generate profit of nothing and end. And this one has a probability of 90%, and that's the chance that we weren't beat to market, and now we can make a decision. So we weren't beat to market. Oh, excuse me. We weren't beat to market, and now we get to collect the information that we get by delaying. So I'm going to change this to a decision node. Let me save real quick here. Save. We have got our event node here, and we want to, now that we know no one's beating us to market, we need to know what the appearance of the demand is. And that appearance, the demand appearance, has a 50-50 chance of being good or bad. So we will add 2 branches there, and we'll say looks good and looks bad. Note, this isn't actually good or actually bad, it's just how it looks. All right, now if it looks good, we are going to Now we're going to make a decision. So based on that information. So we see things that are looking good, and we have now two choices. We can build the equipment, or we can do nothing. So if I build the equipment, let's see, if I choose not to expand, and then I just get 0. So this is no equipment. And now up here, I can choose to build the equipment. And that means now that I need to add, we'll see what happens, right? So the market looked good. Wait, I delayed. It turned out that nobody beat us to market. So now we're waiting for a signal. We get our signal. Our signal is that it looks like it's good. And our choice is, yep, let's build that project-specific equipment. So now that we've built our equipment, we need to see how it actually turns out. So I'm going to add 2 branches. And this is good demand. And down here, this is bad. But notice that now we have to change the probabilities, right? The signal, the looks good signal, is actually meaningful for the real probabilities. So we said this was a 0.75 chance of turning out well, and this was a 0.25 chance of turning out well. If it turns out well, we get our 1800. If it turns out poorly, we lose our 900. Okay. Now if we have all right, and we have no equipment, then we're just done. We need to go back to looks bad though. So now if it looks bad, we have a choice. We can do the same thing, right? Either equipment or no equipment. If we elect to build the equipment, we get the same outcome as here. So I'm going to copy that tree and paste it here. Right, so if it looks bad, I can elect to build the equipment anyway, and then I get good demand and bad demand, but now I need to change the probabilities. So the chance of good demand is 0.25, and the chance of bad demand is 0.75 because we received a bad signal during the delay period. Okay, so we have our 3 choices: to do everything right away, to delay, or to do nothing. If we delay, we have a chance of generating no money from someone else moving in before us. Otherwise, then we get some information and then make a decision based on that information and then wait for the results. So there's the whole big tree, and let's give it a solve and see what the output looks like. So notice here we've got our blue path. So the do everything immediately node is worth 450, do nothing is 0, and then the delay node is worth 506. So it looks like the best decision is to build the building but to delay the purchase of the project-specific equipment. So we delay the building, give up about $60 million worth of value for the opportunity to gather this extra information. So if we build the building, nobody jumps in, and things aren't looking good, then we elect to stop. So we lease the building to somebody else, and life goes on as usual. If things look good, then we build the project-specific equipment and generate a lot of profit because now we've received a good signal. There's a good chance that demand is good. So critical steps in solving this particular problem was to think carefully about what order things happened. If I were to put the demand, good demand, before equipment, no equipment, then you're going to get a different value. That would be more like an expected value with perfect information, because now I'm making my decision based on information that I didn't have. Whereas it was fine to make my equipment, no equipment decision after the looks good information was revealed. because I got that information before I had to make the decision. So the order that events happen are really critical in solving decision tree questions using graphical trees. So there's an example of a rather complex one and its solution.